Your production database just got compromised, and you have no idea how the attacker got in because you weren't capturing network traffic. I've seen this exact scenario cost companies 6 figures in breach response, and today I'll show you how GCP's packet mirroring could have caught it in real time.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm so glad to be here because honestly, network forensics in the cloud has always felt like a black box to me.
Great to have you. Today we're diving deep into GCP VPC packet mirroring, specifically how it works architecturally and when you'd actually use it for troubleshooting.
So let's start with the basics. I know I can look at VPC Flow Logs, but you're saying that's not enough for serious security analysis?
Exactly right. VPC Flow Logs give you metadata. Think of it like looking at the envelope of a letter. You see source IP, destination IP, ports, bytes transferred. But packet mirroring? That's like opening the envelope and reading the actual letter. You get the full packet payload, headers, everything.
Oh, so if I'm trying to figure out what SQL query an attacker ran against my database, Flow Logs would just tell me traffic went to port 3306, but packet mirroring would show me the actual query?
Precisely. And that's not just an analogy, that's technically accurate. Packet mirroring captures layer 3 and layer 4 headers plus the full payload up to the MTU configured on your mirrored instance. By default, GCP uses a 1460-byte MTU for the entire packet, but if you've enabled jumbo frames, you can capture packets up to 8896 bytes.
Walk me through the architecture. How does GCP actually capture this traffic without impacting my application performance?
This is where GCP's implementation is clever. You create what's called a packet mirroring policy. This policy has 3 components: mirrored sources, which are your VMs or subnets you want to monitor, filters to specify what traffic to capture, and a collector destination. For the collector, you can use an internal TCP/UDP load balancer fronting your analysis VMs, or you can configure an instance group behind a forwarding rule directly.
Wait, why would I choose an internal load balancer over a direct instance group setup?
Great question. The ILB approach gives you better scalability. If you're mirroring high traffic sources, you need multiple collector VMs to handle the load. The ILB distributes mirrored packets across your collector pool. Both approaches use GCP's Andromeda virtual network stack to efficiently copy packets with minimal impact to your production traffic path.
So the mirroring happens at the hypervisor level, not inside my VM?
Exactly. GCP's documentation confirms this happens in the virtual network layer. Your VM CPU never processes the mirroring operation. The Andromeda SDN controller intercepts packets as they traverse the virtual switch and creates copies that get routed to your collector. Your production traffic sees minimal performance impact, though I should be clear that GCP doesn't guarantee zero latency, especially under very high mirroring volumes.
That's reassuring. Now what about the filters? Can I be selective about what traffic I capture?
Absolutely, and you should be. Capturing everything generates massive data volumes. The filter options include IP ranges using CIDR notation, so you could specify 10.128.0.0 out of 16 for a specific subnet. You can filter by protocol, TCP, UDP, ICMP, or all. And you can specify port ranges, like ports 443 and 3306 for HTTPS and MySQL traffic only.
Let me make sure I understand. If I set a filter for TCP port 22, I'd capture all SSH sessions to and from my mirrored sources?
Correct. Both ingress and egress SSH traffic matching your mirrored sources. One critical detail though, the filter applies to the mirrored sources, not the collector. So traffic between your collector VMs and the ILB isn't subject to these filters.
What about the collector side? What software do I need running to actually analyze these packets?
Your collector VMs need packet capture software. Common choices are Zeek, formerly called Bro, for security monitoring, Suricata for IDS/IPS analysis, or even cpdump for basic captures. The mirrored traffic arrives as standard network packets on your collector's NIC, encapsulated in GRE, generic routing encapsulation, with protocol number 47.
GRE encapsulation? So I need to decapsulate before analysis?
Most modern tools handle this automatically. But yes, the original packet is wrapped in a GRE header. The outer IP header has your collector's IP as destination, and inside you'll find the original packet exactly as it traversed your production network. Wireshark, Zeek, and Suricata all decode GRE natively.
What's a common mistake people make when setting this up?
The biggest one I see is getting firewall rules wrong. You actually need 2 separate rules here. First, allow GRE traffic, that's IP protocol 47, not a port number, from your mirrored sources subnet ranges to your collector VMs. Second, if you're using an ILB, you need a separate rule allowing health check traffic on your configured health check port from Google's health check ranges. That's 35.191.0.0 out of 16 and 130.211.0.0 out of 22. People often conflate these two rules and end up with collectors that receive nothing.
Any other gotchas?
Cost awareness is important, but the good news is better than many people think. Mirrored traffic within the same zone is actually free, just like regular VM to VM traffic. Where costs add up is cross-zone mirroring, which incurs standard interzone network charges, and cross-region mirroring, which gets expensive with inter-region egress rates. So keep your collectors in the same zone as your mirrored sources when possible. Also, packet mirroring works with compute engine VMs and GKE nodes, but there's a nuance with GKE. Since GKE nodes are compute engine VMs, you can mirror their traffic, but pod-to-pod traffic within the same node might not be captured depending on your CNI configuration. If traffic stays local to the node and doesn't traverse the VPC network layer, the mirroring point won't see it. You cannot mirror traffic from Cloud SQL, Memory Store, or other managed services directly.
Let me recap. Packet mirroring captures full packet payloads at the hypervisor level, sends copies via GRE to either an internal load balancer or instance group fronting collector VMs, and I use filters to control what gets captured. The main use cases are security forensics, compliance auditing, and deep network troubleshooting where flow logs aren't enough.
Perfect summary. My pro tip: start with narrow filters in a dev environment first. Mirror just one subnet and one port range, verify your collector pipeline works, then expand. Don't mirror your entire VPC on day one.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And if you're setting up network security monitoring in GCP, share this with your team. Thanks for watching the Network Ninja Cloudcast. See you in the next one.